I wholeheartedly believe in electric vehicles, but the vehicle's sitting parked most of the time. The impact I'm having by going from internal combustion to electric is that 1 hour driving per day. I'm not burning gasoline, I'm using electricity instead. That's great. The applications that our batteries are going into would have used, let's say internal combustion for 22, 23 hours a day. And now they're being electrified, right? So a significantly higher impact on the electrification is what we're enabling with our technology.
Welcome to Sustainability Leaders. I'm Michael Torrance, Chief Sustainability Officer at BMO. On this show, we will talk with leading sustainability practitioners from the corporate, investor, academic, and NGO communities to explore how this rapidly evolving field of sustainability is impacting global investment, business practices, and our world.
The views expressed here are those of the participants and not those of Bank of Montreal, its affiliates, or subsidiaries.
Welcome. My name is Stephen Uwazota, and I'm Director of Sustainable Finance and Clean Energy at BMO. On this episode of Sustainability Leaders podcast, I have the pleasure to welcome Raj DasGupta, Chief Executive Officer at Electrovaya, a global supplier of safe and long-lasting lithium-ion batteries. In our discussion today, we will focus on the science of enhanced battery safety, the economics and supply chain of building a global lithium-ion battery supplier, and finally, the tailwinds and headwinds facing this energy transition pillar. Raj, welcome to the show, and thank you so much for being here.
Stephen, great to be here, and thanks for having me. It's good to see you again.
Absolutely. So maybe tell us about a quick introduction of yourself and Electrovaya, your background, and how your role and leadership has evolved at Electrovaya.
So I completed a PhD in material science around 2009. And the research I was involved with at that time was related to lithium-ion battery anode materials. I joined Electrovaya after that, and it was a very interesting time in lithium-ion batteries and at the company in 2009. So for those of you who remember, President Obama had just been elected and had made electrifying vehicles a key target of his administration. So the targets were laid out, and major automakers were getting bailed out by the government and were keen to demonstrate enthusiasm as well. So we had partnered with Chrysler for a few of their plug-in hybrid vehicles they were planning to demonstrate in partnership with the DOE in the US. And there were other battery companies as well. Notable ones was A123 Systems. Tesla was a new company as well. Now, Electrovaya remained focused on automotive applications for some time. And I went along with that. I was in research and development, and I developed energy storage systems. But technology keeps developing, we're developing, and the scale of this industry is moving at a lightning pace. And what ended up happening by around 2017 or so, we found ourselves much smaller than our Asian competitors, like out of Korea or China, and they could outprice us in this automotive space. But we also found we had innovated new battery technologies, one of which we thought had huge promise. And that was a technology which we now call the infinity battery technology. And that technology enabled much better battery safety and much better cycle life, so the longevity of the battery. And we pivoted the company entirely. What's happening in warehouses is there's lots of electric vehicles inside warehouses. They operate 24/7. They're inside buildings. So both the safety and longevity portions were highly valuable in that space. And we pivoted the company into that space. I took over as CEO about 3.5 years ago and have really driven that commercialization quite rapidly. So the company's been growing quickly.
Thank you, Raj. That's a very good flyover from Electrovaya's roots and how you've been innovating to sort of stay at the cutting edge of the market. Sticking with that theme of innovation, My understanding is lithium ion hasn't always been the dominant energy storage or battery technology. How did that happen? Are there scalable alternatives to lithium ion today? And how do you think about the future of innovation in this space? Will lithium ion continue to be the standard bearer? How do you manage for that future state where things might change? Maybe they might not, but curious to kind of get your views on, you talked about the pace of innovation in this space. Curious to get your views on how this innovation has stacked up and where you think it's going.
So most certainly the battery space and the lithium ion space in particular has been innovating rapidly since the early cells in the early 1990s came out. And so if you even just look at our products over the last 5 years, they have certainly progressed in performance. That being said, the public is used to, maybe likes to compare the battery space with the semiconductor space. And the semiconductor changes are at, Moore's law, much faster rates of improvements than can be met with a chemical based system, which is what a battery is. So batteries have some limitations in how rapidly they can be improved. And it comes down to chemistry. So chemistry wise, lithium ion is a very, very good chemistry basis for a battery. The reason being is lithium is the lightest metal on the periodic table. It's number 3. Because of that, it has a much higher energy density from a fundamental basis. So a lithium carrier in a battery is hard to beat. You can change the lithium ion. You can have it lithium paired with a different materials in there, but as an energy carrier, lithium is definitely, from a fundamental point of view, difficult to beat.
Thank you for that very insightful view there. You mentioned material handling. You talked about how Electrovaya pivoted from the OEM side of things to material handling. Can you give our viewers a sense of how that shift happened, how large that market opportunity is, and how Electrovaya continues to sort of support that enhanced safety requirement and cycle life requirements of that segment?
Great question, Stephen. So I'm an early adopter on electric vehicles. They're wonderful devices. I had a 2011 Nissan Leaf, and my father still drives a 2014 electric smart car, which uses our battery technology, by the way. So great battery technology is still working. The Leaf is long gone, but the smart car is working very well. But if you look at electric vehicles, that's their primary goal, is to make the batteries low enough in cost that you can sell more vehicles. And that's great. A lot of technology goes into making batteries less expensive. We found we're a smaller player, and it didn't make sense necessarily to go head to head against companies who have much larger footprints and capacities and can do that lower cost efforts better. We'd also found a way to enhance the performance of this technology in a way which makes it highly valuable for much heavier use applications, and applications, frankly, which are more sensitive to safety than cars. So if you have a fire in a battery that's in an electric car, which has happened, of course, many times, it's not necessarily the end of the world. You can probably get out of that car. You've got 4 doors. It's usually outside. But if it's in a warehouse where you may have hundreds of vehicles inside the building and a battery catches fire in there, it's a different story. It's a much more dangerous event. And the other difference is, again, I'm on my 4th electric car. Those cars spend most of their time parked, right? 23 hours a day they're parked, and 1 hour a day it's being in use. And so in terms of the amount of cycles you're doing on an electric car battery, it's not tremendous. In the life of a car, you might be in a couple hundred cycles, maybe 1,000 cycles. Your cell phone works for 2 years very well, right? And then after 2 years, you notice, hey, the battery, I charge it many times a day and it's failing me. I should get a new phone. And 2 years of life on your phone, roughly one cycle a day, give or take. That's about 800 cycles before that cell phone battery reaches its end of life. An Electrovaya battery is doing 15,000 cycles. So it's very, very long lasting. Does an electric car need that? Not necessarily. Does a cell phone need that? No. You want to get a new phone before that. But if you're operating vehicles or robots 24/7 in warehouses and doing multiple cycles per day, multiple charges per day, that really matters for life cycle cost. And that's what we went after. And so it was a new space in general. This is the e-commerce, again, expanding in a similar period of time as well. Warehousing automation is just going gangbusters in that space. And so, like any business, timing is also technology is one part, and finding the application and getting the timing right is the other. And in this case, I'd say Electrovaya finally got it right.
Thank you for that, Raj. I wouldn't have sort of connected e-commerce readily with batteries and energy storage. So thank you for helping us see those connections. And maybe switching gears a bit to kind of speak about the business model and maybe kind of spend a little bit of time on everybody's favorite topic, which is supply chains. It takes a fair bit of putting together technology, materials, and a whole host of other factors to get from raw lithium to product. Can you walk us through how global is your supply chain? What advantages do you have being a North American supplier with a footprint in the US and in Canada, if any advantages?
Right now, our core supply chains come from all around the world. In general, the company, under my direction, we've focused ourselves to become less reliant on supply chains, especially in China, which is why we decided to build the facility in Western New York. That was one reason. The other reason, of course, is expanding our capacity and basically coming back to the roots of vertical integration. But the supply chains and batteries are complicated. One part is in the materials. More importantly, actually, is in the processing of those materials and getting them to the right level where you can utilize them. Now, us being a smaller battery manufacturer and one focused on what our technology provides, our technology is mostly around the way the lithium-ion cell is designed and made, and around a ceramic separator technology, which we also have a significant IP around, and around electrolytes. In terms of the commoditized portions of the battery, we've generally tried to leverage other experts on that and leverage the existing supply chains.
That's helpful. And you talked about setting up shop in Western New York. Talk to us a bit about, are there any complexities in terms of talent acquisition or talent for the processing side of sort of the more technical aspect of that? Just given some parts of the world have had a head start relative to North America, are there opportunities you're seeing on the talent side, kind of reshoring, vertically integrating your supply chain? Curious on what you've experienced so far.
On the talent side, I think that's what all companies, it comes down to, is the people. We're very fortunate here at Electrovaya. The team I've been working with, the core members have been here for, like 10 plus years and have been involved in setting up manufacturing overseas and are now setting up manufacturing in the United States. So we've done it before. We are also finding is the talent pool, both in Toronto, where we are here, we have about 40, 50 great engineers and scientists working with various parts of battery development here. And in New York, very pleasantly surprised to see a really good talent pool that's been available.
Thank you, Raj. And as we sort of look at volatility on global trade, has that affected any of your operations? Has that accelerated some of your decisions to become more vertically integrated? Does that create opportunities to differentiate Electrovaya with your end market customers? Maybe speak to how some of the volatility in global trade is impacting your business?
We decided to build this expansion in Western New York before most of this recent volatility began. So the decision today can be seen as somewhat prescient and it is working out to our favor. But we decided Western New York made sense for a number of reasons initially, and now there's more reasons. So the initial reasons were it was relatively close to our existing operations, so we could have talent go there and back and help set up the facility in a seamless fashion. There was low cost electricity in that region. We had negotiated a direct supply agreement with the New York Power Authority. So this is hydroelectric electricity. Battery production uses a lot of energy. So that was a key component. There was an existing manufacturing site at that site we procured, which was used for electronics manufacturing. So a lot of the same infrastructure was in place for us to make batteries at that site. So these are the factors that came in. And ultimately what we wanted was a site which would enable us to increase our capacity. Now, post all this volatility, there have been a host of additional benefits to having that facility. That domestic supply chain, which we can now leverage and help support, is going to be a competitive advantage on its own. There are not very many independent lithium-ion battery sites in North America, period. There's some battery production which is tied to electric vehicle plants, but there's not a whole lot of capacity outside of that. And especially with something like what we make, which is unique. Long cycle life, high safety, that has uses in a whole variety of areas which you may not come to, may not be obvious. Energy storage for data centers. These sites use a tremendous amount of power. They need to have very good energy supply, very stable, high quality electricity at all times. And energy storage is going to be key to that. You want that energy storage to be as close to the load as possible. The load is billions of dollars worth of equipment. You don't want anything hazardous going there. I think we have a great ability to serve that particular space. Even in defense, right? People here think about drones, but there's drones that go up in the air. There's drones that go underwater. If you want a submarines typically, if they're diesel subs, they run on electric power when they're submerged. Up until today, they're typically still lead acid batteries, primarily because navies are worried about the safety of lithium-ion batteries. And so we mitigate that issue with our technology. So I'd say the opportunity size for all sorts of these types of applications with a domestic supply chain that we have, domestic talent, Canada, USA, becomes very, very valuable in the near and long term.
That's super insightful, especially as you commented around those broader applications for defense, for energy storage, given some of the geopolitical elements of that makes obviously your positioning, your location, and your technology all the more valuable. Raj, you mentioned how prescient your decision was to localize your supply chain. Maybe if you could help me with sort of picking out the lottery numbers as well, that would be greatly appreciated. But maybe let's talk about the big elephant in the room, and that is AI and its impact on affordability, reliability. Where does Electrovaya sit in enabling that growth of AI, of data centers, and how do you play a role in sort of driving that sort of important growth pillar for the North American economy?
With AI, it's coming at an interesting time. The advent of and the growth of this revolution is an interesting time for us as a company. And there are various ways we're treating this. So on a software point of view, we are developing our own software which will help warehouses, e-commerce sites, etc., optimize their electricity demands throughout the day using a proprietary software we have. So picture a warehouse. You may have 150, 200 electric vehicles. These might be robots. These might be forklifts, but they're generally large devices. It's use large batteries. And so they use a lot of energy to charge those devices over a 24-hour period. With cost of electricity going up, the optimization of this charging can be very valuable for both the utility company and for the warehouse operator. And so our software is coming out. It is using AI. It will react dynamically to optimize the charging of these vehicles throughout the day with an objective to reduce the electricity demand at peak periods. So it'll take a look at, let's say, vehicle number 68. It has a 60% stated charge. It's been plugged in, but is not expected to be used over the next several hours in a heavy way. So the software will charge that at a lower rate than the next vehicle, which is expected to be used at a much higher rate over the next few hours. So that kind of software is something we're developing and we'll be launching very shortly. So that's one way we're involved with AI. The other is, of course, what you discussed, which is the data centers. And the data centers use a huge amount of power, and they need that power quality to be constant and perfect. So they can't have what you call dirty power, or, it might be any sort of brownouts would not be tolerable for a data center. And so they're looking at battery backup in a big way. And those batteries need to be able to react quickly. They need to have high power throughputs, and they need also to be very safe and reliable throughout the life of these assets. And so our battery technology fits very nicely with that type of use case. And so we're developing products specifically for that purpose.
Let's talk about impact. What kind of sustainability impact does Electrovaya generate? Whether it's avoided emissions, you touched on generating your power from hydroelectric sources, making your overall product life cycle more carbon positive. Maybe speak to that piece for a little bit if you can.
Oh, I'd say we have a tremendous impact. Now, any lithium-ion batteries that are good are having an impact. But I would say ours have a particularly high impact per unit kilowatt hour, or whatever you want to measure it by. And the reason is the batteries last so long, right? The cycle life, going back to that cell phone analogy, cell phone battery after 800 cycles, it is hopefully going to a recycling site. And in many cases, it's not. It might be going to landfill. So that's not good. In our cases, that battery is lasting a heck of a lot longer, right? So it's got a much longer useful life before it gets recycled. And so just off the bat, that's having a much higher environmental impact than a competing technology. The applications that's going in as well reflect that. So going back to the car analogy, I wholeheartedly believe in electric vehicles, but the vehicle's sitting parked most of the time. The impact I'm having by going from internal combustion to electric is that 1 hour driving per day. I'm not burning gasoline. I'm using electricity instead. That's great. The applications that our batteries are going into would have used, let's say internal combustion for 22, 23 hours a day. And now they're being electrified, right? So a significantly higher impact on the electrification is what we're enabling with our technology. And then, as you mentioned, that localization, that domestic supply chains, which we're supporting through our own investments and through our partnerships, that in itself will have a secondary strong impact. So batteries overall are good. They're all helping, and ours are helping a bit more for those reasons.
Thank you so much, Raj. And this was a great discussion. I really appreciate your insights. Just before we go, is there anything you would like to add to our viewers, something that is not as well known about Electrovaya that you would like to leave us with?
Batteries are like Baskin Robbins. There's many flavors, but our flavor is about safety and cycle life. And it's a technology which is now, it's not brand new anymore. It has been deployed. We've deployed over 10,000 systems just in the material handling space now. And these are the very first systems that we installed are actually still in use. They outlasted the vehicles they were installed in that, and they're in their next vehicle. So we're making these very, very robust battery technologies, and I would expect them to be used in a wider and wider array of applications as time goes on.
Thank you, Raj. This was a great conversation.
Much appreciated, Stephen. Thanks.
Thanks for listening to Sustainability Leaders. This podcast is presented by BMO. You can find our show on Apple Podcasts, Spotify, or your favorite podcast player. Press the follow button if you want to get notified when new episodes are published. We value your input, so please leave a rating, review, and any feedback that you might have, or visit us at bmo.com/sustainability leaders. Our show and resources are produced with support from BMO's marketing team and Puddle Creative. Until next time, thanks for listening and have a great week.
For BMO disclosures, please visit bmocm.com/podcast/disclaimer